You're welcome back from break. Let's continue from where we stopped. We come to another concept, yet under coordinate geometry. Equation of perpendicular line. When a line is perpendicular to another, that means that the product of their gradient is -1. M1, M2 equals -1. M1 is the gradient of the first equation. M2 is the gradient of the second equation. The multiplication of the two of them will give -1. If and only if one is perpendicular to another. Example 1. Find the equation of the straight line through -2, 3 and perpendicular to this. The control equation is 4x plus 3y minus 5 equals 0. Let's find the gradient of this. 3y equals 5 minus 4x. Dividing each term by 3, we have y equals 5 over 3 minus 4 over 3x. So the gradient here, M1, is minus 4 over 3. So what is going to be the gradient of the perpendicular line? M1, M2 must be equal to -1. If one is perpendicular to another, M1 is -4 over 3. Now times M2 equals -1. Dividing both sides by -4 over 3, we have M2 equals -1 times -3 over 4, and that gives 3 over 4 positive. If that is the case, that means 3 over 4 is the gradient of the perpendicular line. We now use it to form the equation we need. Therefore, the equation is y minus y1 equals m into x minus x1. That is y minus, what is y1? y1 is 3 equals m is this m2, the gradient of the perpendicularity. So that is 3 over 4 into x minus x1 is -2. So y minus 3 equals 3 over 4 into x plus 2. Clearing the fraction, we have 4y minus 12 equals 3x plus 6. 4 times y is 4y. 4 times -3 is -12. 4 times this, 4 we take care of 4. We have 3 to open the bracket. 3x plus 6, because 3 times 2 is 6. So we have 4y minus 3x equals 18. -12 to go to the other side becomes +12. 12 plus 6 is 18. So that is the equation. Now let's see which one tallies with it in the option. 3x, no, 3x minus 4y plus 18. 3x plus 2y, no. 4x, 5y, no. 5x minus 2y. Now, when you come across a question that is structured like this, it doesn't mean there is no answer there. There is answer. I suspect option A, in which we have all our content, 3x here, 3x, 4y, 4y, 18, 18. Only that they are different in sign. Instead of -3x here, we have +3x. Instead of +4y, we have -4y. And our 18 has been brought inside, which is supposed to be -18, and it is +18. So A is our answer, but how? Use -1 to multiply the equation through. It will become -4y, +3x, -18. And if you bring that in, if you bring it in and reorder, it will be 3x, you know it's positive, negative 4y, bringing negative 18 in, it will become positive 18 equals 0. In fact, that is our answer. Option A is the correct answer. Can you see that manipulation? It's the same thing, but deliberately they mix up the order. So you just realize that by the time you use negative 1 to multiply through, it will change the order to be like theirs. And that is it. Example 2. Under equation of perpendicular lines. Find the equation of the perpendicular bisector of the line joining P to Q. This question demands more than a straightforward procedure from you. You must know what you are facing. Let me demonstrate it so you can see. The line PQ, 2, minus 3. This is the P. Q. This is minus 5, 1. That is Q. This line PQ, a line that is perpendicular to it, not only perpendicular, it is a bisector. A line that is a bisector divides the other line into 2 equal halves. That means this line is a bisector of line PQ and it is perpendicular to line PQ. 2 things are noticeable there. The fact that it is perpendicular means that the product of the line and the other line PQ will be negative 1. That's noticeable. Another thing to note there is that the fact that it is a bisector means that it divides line PQ into 2 equal halves such that this point is the midpoint. So you need to find the coordinate of the midpoint. What is now the coordinate of the midpoint of this line PQ? The coordinate of the midpoint will be half of x1 plus x2, comma, half of y1 plus y2, which is half of negative 3, comma, half of negative 2. So this is minus 3 over 2, comma, minus 1. This is the midpoint coordinates. The coordinate of this midpoint is this. What are we using that for? That is to say that you are calculating, you are finding the equation through the point this. Equation of a line through one point. And which is still perpendicular to the line PQ. So, let's find the gradient of the line PQ. The gradient of the line PQ will be M1, which is Y2 is 1 minus Y1. Y1 is minus 3. All over X2. X2 is minus 5 minus X1. X1 is 2, which is 1 plus 3 over minus 7, which is 4 over minus 7. 4 over minus 7 is minus 4 over 7. Minus 4 over 7 is the gradient of this line PQ. Meanwhile, because they are perpendicular, M1 times M2 must be equal to minus 1. Meaning that minus 4 over 7 times M2 is equal to minus 1. So M2 equals minus 1 times negative 7 over 4. You understand? 4 over 7 will become 7 over 4 because we find the inverse. So M2 will be equal to 7 over 4. 7 over 4 is going to be the gradient of the perpendicular line. And that perpendicular line is going to be through the midpoint because it is perpendicular to it and it is a bisector. Therefore, the equation is y minus y1 equals m into x minus x1. Y minus, what is y1 here? The equation we want to form here is the equation through the midpoint. The midpoint is this. That's why I've taught you the midpoint coordinates before now. So, y1 is -1 equals m. That m is the gradient of the perpendicular. So that is 7/4 into x minus x1 is this, minus 3/2. Y plus 1 equals 7/4 into x plus 3/2. Clearing the fraction using 4, so it will give us 4y plus 4 equals 7x plus 21/2. Clearing the equation again using the 2, we have 8y plus 8 equals 14x plus 21. So we have 8y minus 14x equals 21 minus 8. 8y minus 14x equals, when we subtract 8 from 21, that gives us 13. Now let's scan through our options. 8y minus 14x minus 13. Yes, option A is our correct answer, because we too can bring this in as 8y minus 14x, bringing the positive 13 in, it becomes minus 13 equals 0. So that is 8y minus 14x minus 13 equals 0. Option A is our correct answer. Let's consider example 3, which is going to be the last example I'm going to give you on this. Find the gradient of the perpendicular line to this line. So let's find out the gradient of this line itself. 2x minus 1 equals 2y/3. Clearing the fraction, we have 6x minus 3 equals 2y. Making y subject to the formula, 2y equals 6x minus 3, y equals 3x minus 3/2. Therefore, m1 equals 3. The gradient of this function is 3. And m1 times m2 must be equal to -1 if this is a perpendicular, if that line is perpendicular to this line. So we say m1, which is 3 already, times m2 equals -1. m2 is -1/3. So m2 is the gradient of the perpendicular to that line. Therefore, our correct option is option C, -1/3. That is the gradient of the perpendicular to this line. We come to another concept still under coordinate geometry. Intersection of two straight lines. The coordinate of intersection of two straight lines is obtained by solving the equations of the lines simultaneously. Example 1. Find the coordinate of intersection of lines y equals 3x plus 4 and y equals 2x plus 3. All we need to do is solve the two equations simultaneously, and our answers will give us the coordinate of their intersection. That is, y minus 3x equals 4, equation 1. I restructure this equation. This also will be y minus 2x equals 3, equation 2. Solve them simultaneously. Using the elimination method, I subtract y from y here, subtract the equation 2 from equation 1. That is, subtract y from y, you get 0. Subtract negative 2x from negative 3x, we have negative x, which is equal to subtract 3 from 4, we have 1. Therefore, x equals minus 1. Let me explain what I did here. When I subtracted negative 2x from negative 3x, and I say the answer is negative x, what do I mean? This is it. Minus 3x minus 2x minus 3x plus 2x minus x. That is it. Do you understand? Good. So we substitute this. Put x equals minus 1 into equation either 1 or 2. Anyone. Let me take equation 1. So bring the equation 1 out. Here. Wherever you see x, put negative 1 there. So we have y equals 4 plus 3x. I take negative 3x to the other side to become positive 3x. So y equals 4 plus 3 into, wherever you see x there, you say it is negative 1. So y equals 4, negative 3. Positive 3 times negative 1 gives negative 3. So y equals positive 1. Therefore, the coordinate is x, comma, y, and that tallies with option C. Option C is the correct answer. X, comma, y. Negative 1, positive 1. Example 2. Under intersection of two straight lines. Find the distance between the midpoints of the line x minus y equals 1 and the intersection of lines y equals x plus 1 and y plus x equals 0. Two things are here, two separate things that we still have to relate together. The distance between the midpoint. What's the midpoint of this line? X minus y equals 1 is a straight line. Its midpoint will be when x equal to 0, comma, y will be equal to minus 1. So we form 0, comma, minus 1 as a coordinate. So when y equals 0, you can see x is equal to 1. When y equals 0, put it there, x will be equal to 1. So we form 1, comma, 0 as the other coordinate. The midpoint of these 2 points will form the midpoint of this line. So midpoint equals half of 0 plus 1, that is x1 plus x2, half of it, comma, half of y1 plus y2, which is half of 1, comma, half of minus 1. Answer is half, comma, minus half. This is the midpoint. Then the intersection of these two lines also, intersection will be y minus x equals 1, equation 1. Y plus x equals 0, equation 2. Midpoint of two lines is the solution of the two lines simultaneously. This is 2y plus 0 equals 1, y equals half. Solving it simultaneously. Put y equals half into either equation 1 or 2. We have y minus x equals 1, half minus x equals 1. That is 1 over 2 minus 1 equals x. So x equals minus half. So x is minus half, comma, y is half. That's the coordinate. We are now to find the distance between this and this. That's the question. Find the distance between the midpoint of the line this is the midpoint, and the intersection of the lines this and this is the intersection. We are finding the distance. So the distance will be square root of x2, this is x1, this is x2, x2 minus x1 all square plus y, this y1, this y2, y2 minus y1 all square, that is square root of minus 1 all square plus 1 square. Because negative times negative is positive. Half plus half is 1. Square root of, when you square negative 1, it gives you positive 1. Plus square positive 1, it gives you positive 1. 1 plus 1 is 2. That is the answer. And that tallies with option D. Option D is the correct answer.